Okay, good day. This is Dual Enrollment Pre-Calculus. I am Mr. McCulley, and this is a special fraction supplement. So if you feel good about adding and subtracting fractions that have trigonometric denominators in them, then you can skip this. Otherwise, you might want to pay attention and follow along. So all we're going to talk about is how we're going to add and subtract fractions that have trigonometric denominators. And so I just have a couple real quick little examples here. Um, when you were taught how to add fractions, the first thing that they taught you was if you just add across the top if the denominators are the same. But if the denominators are not the same, then you have to find a common denominator, and that's kind of a least common multiple. Now, in the case of trigonometric functions, which is what we're going to be using here, we can kind of consider the denominators the same way that we consider these two prime denominators, 5 and 7. Both 5 and 7 are prime numbers. And so when I want to find a common denominator with these two prime numbers, the only example, or usually what I'd look for would be a least common multiple. But in this particular case, the least common multiple is when I multiply both of them together. The least common multiple between two prime numbers is just the product of those two numbers. So in this case, my least common multiple is going to be 5 times 7, which is 35. And so to get that, to get a common denominator here, I'm going to multiply by my funky 1, and it's going to be the opposite denominator. So here, since I want to change 3/5 into something in terms of 35ths, I'm going to multiply by 7 over 7. And over here, I'm going to multiply by 5 over 5. So 7 times 3 is 21. 5 times 4 is 20. And then I get 35 on the bottom for both of these because 7 times 5 is 35, and 7 times 5 is 35, giving me a final answer of 41 over 35. And I don't think I can reduce that, so we'll leave it as that. Now we're going to do basically the same process, except we're going to have terms of sine and cosine. So just like we looked at the denominators here and multiplied the first fraction by the funky 1, which was the second fraction denominator, and then we multiplied the second fraction by the denominator of the first fraction over itself, we're going to do the same thing with expressions like this. So I'm going to multiply this first one. I'm going to come over here and multiply this one. It'll be sine theta over sine theta. And then this one will multiply by the opposite, and a funky 1, cosine theta over cosine theta. And so we remember that sine times sine would be sine squared theta, and that cosine theta times cosine theta is cosine squared theta. And I'm going to leave this unmultiplied in the bottom just for a second. Sine theta times cosine theta. Now we remember our trig identity cheat sheet that says sine squared theta plus cosine squared theta is equal to 1. And so I can make that substitution and go sine theta times cosine theta. And technically this would be okay as a final answer, but remember, when you have multiplication, you can separate it into two fractions, because multiplication, you just multiply the numerator and the denominator. So I got sine theta times 1 over cosine theta, and 1 over sine theta is cosecant theta, not cosine theta. Come on, Macaulay. Cosine theta is cosecant theta, and then 1 over cosine is secant theta. And so either this is my simplest form or this is my simplest form. I really don't care. Just know that both of those are the same things, just in case you're checking the back of the book and they have it a little bit, they have it like this. The last one I have for this one is, again, if we have these opposites here, we get a nice funky one. So I want to multiply this particular one by 1 minus cosine theta over 1 minus cosine theta. And then this one here I'll multiply by 1 plus cosine theta over 1 plus cosine theta. And remember what happens here when we have a plus b times a minus b, we get a difference of squares, that special factoring form. So we get a squared minus b squared. And so if I distribute here, I get 1 times sine is sine theta, and then negative cosine times sine would be negative sine theta cosine theta. And then when I distribute the cosine to both terms, I get cosine times 1 is cosine theta, and then cosine times cosine is cosine squared theta. I may not be able to do a whole lot with this one. And then in the denominator here, I'll have, let's see here, it'll be 1 minus cosine squared theta. And again, using this Pythagorean identity, if I subtract cosine squared theta from both sides, let's go back to this one, it'll be sine squared theta. So this will be sine theta minus sine theta cosine theta plus cosine theta plus cosine squared theta all over sine squared theta. I have no other terms that I can combine, and I have no factor because there's 1, 2, 3, 4, 5 different terms here. I don't have a common factor that I could factor out to reduce the denominator at all. So I think we are stuck with this as a final answer for that one. All right, since this is just a quick supplement, there's no super fabulous fun fact of the day. Thanks, and goodbye.